Okay, hello everyone. Thanks for coming back to part two of making a Rubik's Cube solver in Python with a recurrent neural network, probably, I think. Um, Before we get into it, I guess I'll just make some sort of general remarks about where I'm putting these up and what my thinking is. I didn't intend to put these up on my old YouTube channel where I was making the comic book videos and you know, increasingly social war culture war type videos I was making. But I was just kind of making it for fun, but then I went to YouTube and I saw that somehow people were still commenting on those videos from like 6 years ago, many of which were unlisted, and saying like really nice things. It was very humbling to read some of the things people were writing, particularly about a bunch of videos that I, have reservations about now. So I thought, this will be a pretty hard pivot for the channel, but there are still subscribers and people are still apparently interested in hearing from me. So I thought I would just add these videos to that channel, and if people want to watch me do things and hear from me, then great. Hopefully you're interested in programming. Otherwise, maybe at some point I will go back and do a retrospective on what I was trying to do with those videos and where I think they failed, and maybe I'll also make some new stuff I like about my thoughts about some books and like society's irreversible decline over the past 6 years. Yeah, I think there's probably a fertile kind of subject for discussion there in that, I think. So, stick around. We'll see what happens. For today, what I was thinking we could do in terms of actually advancing this project is I wanted to start creating the classes and the sort of software objects that are going to simulate the Rubik's Cube itself, which, I mean, this is kind of the basis for creating the training data, and also I think this will be the basis for visualizing the cube. So a couple thoughts on that. I think in the first video I talked about how I'm not aware of how you do 3D graphics in Python. It turns out there are heaps of ways to do 3D graphics in Python, and I'm just an idiot, and that's that's always nice to discover. So I think I'm not really familiar with like PyOpenGL, which looks like one option. I mean, it might be possible to do it in like Matplotlib as well. Not that I know anything. I mean, not that I'm any good at that library either. But I think there are 3D options, and so maybe I'll explore those later if I feel like it. But I think what I'm gonna do is first of all simulate the cube itself, just in terms of software classes and as like object-oriented programming concepts. And then I will have a secondary Python like class that actually visualizes it, and so we'll visualize it in 2 dimensions to begin with, and then I could make another visualizer after that works in 3D if I want to try and do that. It seems kind of daunting to me right now, and also not really what I'm after. But anyway, we'll park that for the moment. Today I just want to make the classes for simulating the cube itself. And so what I have in mind with this is basically three classes, three pretty small classes, or at least two pretty small classes. And they're going to be, one class is the cube, which is going to be just an object that takes in parameters of 6 sides. So it's just going to be a custom data object that has basically 6 sides in it, and then we're going to have a second class which is a side class, and the side class will contain 9 squares because each side has 9 squares on it, and then we'll have a square class which is going to be super basic. It'll literally just be one particular square on one given side, and I think all it will do is basically take assignment of a color, so one of the 6 colors available on a Rubik's Cube. And then, we can have a bunch of methods in the cube class that allow us to sort of randomize the cube and keep track of the moves that are being made. And probably like a move method that will, you could give it like a right turn or a left turn or whatever, and it rotates the cube accordingly. Something like that. So I think in terms of how we do all that, I've been looking at this website this morning, which has some helpful notation on it about how how to describe the Rubik's cube. So I think the sides of the cube are normally described in terms of, like, it appears to be front, upper, left, right, bottom, and back, or something. Rubik's cube notation, you'll be able to... I mean, that's... Unfortunately, I can't see the other side of this picture, but I wonder what the advanced notation looks like. Front, right, upper, left, back, and down? Down, okay. Face rotations, slice turns, 2 layers at the same time. So there's like some of these like rotations, like rotating 2 layers at the same time or rotating 1 layer twice. I think we could just represent that as, the rotate, like one rotation and then another of the same rotation. I don't know that I want to implement all of this, but that's fine. A half turn is the upper face. So the thing I'm not understanding right now, immediately, is how do you... Like, how does U, a 90-degree clockwise rotation in the upper face, how does that indicate that it's... Okay, so U is right, the upper face. Oh, interesting. So, and U dash is a 90-degree counterclockwise rotation of the upper face. Interesting. So we're rotating the... So the rotations are described in terms of which face of the cube is being rotated. Right. Okay. Okay, that makes sense. So, like, I guess we could initialize... each side of the cube with kind of whether it's the front, whether it's the up side, whether it's the down side, the left side, the right side, or the back side, and then use that. Maybe it could be like an enumerated type. I haven't played around with enumerated types in Python very much. I remember them being useful in Java sometimes. And then you could use that enumerated type to designate each of the pieces on the cube, and then we could, in terms of calculating where they end up, I mean, that's an interesting problem. Okay, I might just start writing some code. I mean, terrible idea to just start writing some code when you don't fully understand what you're doing, but let's just see how far we get, and then when it inevitably doesn't work, like the way I see this video is going, right, is I'm just going to make this stuff up, and it's inevitably going to fail, and then, I'm going to look very foolish, and then I'm going to come back with a newfound zeal to try again in a different way, and I'm going to learn things by getting it so completely wrong the first time, and that's exciting. It's exciting to, like, learn how wrong you were. So let's have a go at this. So we're going to define a class cube, and I think now I'm not sure, like, do I want the cube to take in as parameters the sides, or do I want the cube to I think I want it to initialize the sides, right? Because, like, why am I going to pass in the sides? Like, if it's, we're going to but then I suppose if you wanted to initialize a cube from a unordered state or a random state, well, not a random state, but like a particular state that is not the original state where you have 6 faces with solid colors on each face, then okay, so we could have optional parameters perhaps. I'm going to replace these nuns with the side constructor, and that will initialize those sides once this constructor is called. So we're going to have like cascading constructors. So that's probably the foundation of that class. Let me I'll create a side constructor like this, class side, and again, we might want to have optional parameters for this that allow us to say which colors exist in which regions of the side. I don't know, and we could just have you could just pass in a string of the colors, or a string, or not a string I suppose, but a list of enumerated types. I think I want to use enums for this, and I'll have to look up how they work in a second, but I'll just say, I'll leave a note here, could make optional parameters to initialize custom side colors. Okay, but we're not going to do that now. So, and then we initialize this. So we're going to say initialize 9. I don't know if each of the blocks have a particular name, but I guess I'm just going to call it squares. That's what I was calling it before. I'm probably bastardizing the whole science of solving a Rubik's Cube here, but here we are. It doesn't matter. Initialize 9 squares. So we're gonna just create 9 squares, and they will. So I think, okay, yeah. So we need to give those a name. Each of the squares needs to have a name, and I think the side needs to have a name as well. So maybe the side needs to take an argument which is just side. Side is not defined. Oh, okay. Red equals 1, green equals 2, blue. Interesting. Second, define the color class that inherits from. By definition, enumeration is a set of members that have associated unique constant values. Enumeration is often called enum. Python provides you with the enum module that contains the enum type for defining new enumerations. You define a new enumeration type by subclassing the enum class. Shows how to create an enumeration called color. And this sounds exactly like what we're trying to do. So you import the class, and then your class inherits from that. Yes. So what does this assignment do? Therefore, the names are in uppercase letters by convention. In this example, the color is an enumeration. The red, green, and blue are members of the color enumeration. They have associated values 1, 2, and 3. The type of a member is the enumeration to which it belongs. The following illustrates the type of color .red is the color enumeration. Okay, well, let's just have a go at that then, I guess. Okay, so from enum, import enum, and then class color, inheriting enum, we go, so by red equals 0. According to the website, actually, it said cubers who use this color scheme usually start with the white face and finish with the yellow. So white is on top then. I don't know. I guess we could say right equals red. Sorry, what am I doing? I'm doing colors. Red equals 2. I also keep confusing the sides with the actual colors, but I think what we want to do is encode the different possible colors. Sorry, there's a lot of noise outside now. I don't know if you can hear that, but what I think we want to do is try and encode the different possible colors. Such that we can just represent it numerically. So, like, we could have a representation of the cube starting from like 1 point on the cube and just read off a string of numbers, and that will tell us what the color of each square is. And if we have numbers representing each of the colors, that would make that possible. So, yeah, with these enumerated types, we should be able to do something like that, I think. Or maybe not. We'll see. So, orange. So green, white, red, and orange. Green, white, red, orange, and then I guess blue equals 4, and then yellow equals 5. Okay. So, I'll just make another enumerated class for this. So class sides, and that needs to inherit enum as well. Makes sense. We'll go front. Sorry, this needs to be capitals. Front equals 0. White is up, so we'll just try to keep a parity here. Up, and then red is right equals 2, and then left equals 3. Back equals 4, and down equals 5. Okay, so the side class takes in side name, which we're now giving it. And if the colors are equal to none, then I think what we could do. So I mean, the advantage. Okay, so here's one purpose for the enums already. If there is no optional parameter for the colors, then we could just check what the number of the side is, and then get the corresponding color enum and make all the squares on that side that color, and that way we would, have, oh, okay, this side is the front side is, front has the number 0, and 0 corresponds with green, therefore all the squares are going to be green on the front side. Okay, so I feel like that makes sense. So, let me just write that out. So front left up, front up, front right up, front left, front right, front right down, front down, and front left down, like that. So 1, 2, 3, 4, 5, 6, yeah, it's 9. So, and the other thing we're going to have to talk about at some point is padding, because we want these to all be the same length, even though they don't need to be. But I don't want that to confuse the process any more than it has to. So, in this case, it goes left, nothing. Like, maybe what you do is you leave the space in the middle. And then... So what is it? It's this the notation is side, so side of cube. And then is it row of cube? No, it's like column of cube. Column of cube. And then it's like row of cube after that. We can go, so we have the side name, then we have the row name in here, and then we want to, I need to put a line on my screen so that I can know where the video cuts off. Yeah, I'll look at that later after I've irritated everyone over and over again by working on things off screen. Yeah, maybe I should just change how I'm doing it. Anyway, well, there are a few things to work out. You know, we'll get to it. We'll get to it. I think we will get to it. All in due. Yep, all in due time, my friends. Okay, so the second initial, so for column in columns, square name e2 equals column. Okay, so that should give us a square name, and then once we get down here, we can, I guess what we want to do is add square to list. I think we're going to do it as a list, so I will declare a list up here before the big bad for loop. Declare create list of, sorry, that's pretty off screen as well, isn't it? Create list of squares. Yeah. This is always the trouble, you know, you like start making names, and then I guess we want self.squares to be equal to a list. And then add square to list, so we're going to go self.squares.append and then append a square to the list, and we're going to pass in the square name, and then if we don't pass in a color, I think we will infer the color of the square based on the first initial of the square name, and that way we can keep track of, that way we can figure out what color it should be, because this is a solved cube, presumably. Okay, so let's go over what I've got here. So I've got a cube with these sides. When you initialize a new cube, you get 6 sides, and then each side gets initialized with the side constructor. The side constructor creates a side containing 9 squares. Each square gets a label, and then each square being a square name, and then if based on the name, if a color is not specified, we generate a square with a color that reflects the first initial of the square name. I might have to do some research to figure that out. Known as a hashable, access an enum by name and value. Because the enum implements the getItem method, you can also use square bracket syntax to get a member by its name. For example, the following uses the square brackets to get the red member of the color enumeration by its name. Since an enumeration is callable, you can get a member by its value. Okay, for example, the following return the red member of the color enumeration by its value. Okay, cool. So that's cool. So I can so you use like parentheses to do that. Let me go back to the scene then. So I want to get the color by calling the square name the first element of the 3 tuple that is the square name, and that gives you the color. But that's only if color is none. So if not color, then color. Then self.color, otherwise self.color, sorry, it should be an else. Self.color equals color. I mean, I guess the color doesn't. So what changes? Like, I guess it is immutable. The color of a square is immutable, but its position on the cube can change. So, do we want the sides to keep track of what the sides should keep track of, like, the front side is always going to have a front right upper square, yeah? It's just that the color of that could be any of 6 different things. Whereas each square is always going to have a color, and it could be in any given position. So I guess it makes sense for the square to keep track of, I'm gonna write this down, square color is immutable, and that just means it doesn't change. Square keep track of color. It's always good to write things in caveman speak, I think, when you want them to be as simple. Like, just get rid of grammar. Grammar is just such a nuisance when you're trying to explain something very simple. I don't know if that makes sense. And then we go up here. So we want side keep track of side square position. Maybe so squares on a side are immutable. Side keep track of squares, I guess. But then I think I'm not one to mess with matrices, but I think there's probably some matrix math here that would make all of this a lot simpler. Yeah, I'm not going to be doing that though, because I have no idea how. Okay, so is there some simple test I could run on this to see what I've got? Yeah. Alright everyone, to avoid doxing myself, I've changed the prompt that appears in my console. And it turns out to do that on a Macintosh, what you can do is you can open the .zshrc text file from your I think I can show you this and it won't cause any harm. You can open this file from your root directory, and then you just add this line containing the prompt that you want, and this will display only the directory, the current working directory, which is good if otherwise you'd be showing what your entire full name is. So thank you to, I don't want to dox this guy, but that guy, for figuring that out for me, so I didn't have to think about it. Okay, so let's go back over to here. We're back here in this directory. Let's open the Python interactive shell, and that's what it's called. And then if we go from cube, import cube, capital C cube, side, and square, and then we'll have this, and then we go, let's go new cube equals cube. Okay, yeah, so this is where I was having an error. Like, tuples are an immutable data structure, so once you declare a tuple, you can't change the value of the tuple. You have to just make a new tuple, which is fine, great, really, it's great. Tuple does not support item assignment. What do you mean? I'm not trying to... I've quit out of that. I'll clear this. I'll run the Python shell again. Then we go from cube, import cube, side, square, like so. And then we have, oh god, okay. We declare a new cube, and the cube is this. I'm sorry. We're passing in an enum for front, up, right, left, back, or down. So I thought on my reading the documentation that you could just pass in one of these enumerated types that would, you know, sound in terms of one of these numbers, and then one of these numbers would allow us to convert it back into one of these colors. But apparently that's not how it works. So I need to, is there a way you can get the value for a side or something? We need to index into the color enumerable, whatever it's called, enum, with like this. This is an example of how we get it. So if we go into the side enum with a given side, that'll return a value, and then we can use that value to get a color back. So if I go back over to the scene, the other scene, we go into the side. Okay, and that should give me a color, I think. Yeah. Okay, let's go back to iTerm for a second. It's annoying, unless I'm sure there's going to be a shortcut to like clearing everything on your terminal without quitting out of the thing every time. I'll check out it. I'll figure out how to do that. From cube, import cube side square. New cube equals cube. Hang on, did that? I think you need to declare, I mean, Python might let you get away with it, but I think you meant to use the parentheses. No, okay, side is not subscriptable. Is it perhaps the case that I don't understand how the Python interpreter works, and like you only get the version of the code that you've imported when you import it? I mean, maybe that's it. We'll go from cube, import cube. We go new cube equals cube. Okay, so now I'm seeing the hellos at least. Here is the side's front. Right, okay. Okay. Key error equals 0. Okay, cool. I mean, that's way better. So the side, yeah, that makes sense. Annoying that I wasted that time, but that's fine. So now we can try and, I guess if I re-import the key error 0, I don't know, it's still got the same version. Okay, let me try. So annoying that you have to go through that every time. It remembers the commands though, so that's helpful. Okay, so the side of the cube is front, the value of the side of the cube is 0, and the color is green. So that's if I go color equals green. So if I, I see. So all I need to do then is get rid of this, and just, because you're calling the value directly. I wonder if maybe that is what I meant to do all along. Let me just check that. Print color. This is me learning how to use this basic feature of Python, by the way, which is pretty good. I don't know. It's funny. Like I don't want people to think I'm holding myself out as an expert in any of this, because I'm not. I really just find this stuff really interesting, and so I'm just trying to figure it out. At the same time as making these videos. So I hope people don't think that I hope people aren't coming here for instruction, because you're going to be sorely disappointed if that's what you're here for. Yeah. All I need to do then is change this thing to say color side dot value, and that should set the color accordingly. Okay. Okay, so I wonder if that'll let me initialize the cube now. And I think, what's becoming clear to me is that I'm probably going to have to come back and refactor all of this later on once I've figured out how to do this properly. So most of this is going to get thrown away, I think. But let's just try to get it working, and then we can worry about that afterwards. Okay, so it just says hello. So it worked that time. So I don't have a string representation for a cube yet, but I can probably just go into the new cube, go to the front side of the cube, and just return that value. And there we go. Hey. So, okay, so this is like the top. That looks like a lot more than what I expected. So I guess this is the top. Man, that's a lot. That's way too many, in fact. I think my math is off. I think, yeah, I'm iterating over this way too many times. That's what I'm realizing. So I'm doing 9 iterations over, like, there are 3 rows and then 3 columns, right? So 9 times 3 times 3, so 81 squares instead of 9 squares. So I think actually we don't even need this first. I don't know why I thought I did, but like you just start with the top row, and because the side name is always going to be the same, so yeah, that can go. Yep. Hello to you too. Okay. This looks much more promising. So we've got the front upper left, so 0, 0, 0, color green. We've got front upper mid, 0, 0, 1, color green. Front upper right, color green. Front mid left, color green, so that's 0, 1, 0. So then front mid mid, 0, 1, 1 is green, 0, 1, 2 is front mid right, color green. Front down left, 0, 2, 0 is green. Front down mid is 0, 2, 1. Front down right, 0, 2, 2 is green. So that's all of them. So there you go. We've got a representation of one side of the cube, which is what we're after. Here are the sides I just put in. So as you can see, we've got 6 sides in our cube, and they are all the colors you would expect them to be. So that's cool. So yeah, I guess in the next video, I'm going to try to clean this up, and we will think about how we rotate it, and if we can create a method to rotate it that actually makes sense given how we've set this up. I'm not sure about that, but we'll have a go. So yeah, thanks for watching.